everyone, welcome back. In today's video, we'll explore a super useful Node.js module, that is Zlib module. Let's get started. The Zlib module in Node.js is a built-in module that provides compression and decompression, means perfect for saving space and speeding up file transfers. As explained in the last video, it is a kind of transform stream. Think of it like a digital vacuum packer. It shrinks your data to make it smaller and later you can unpack it back to its original form. But what is the use? Let's say you are working with large files in your Node.js application. Compressing them with Zlib can save storage and even reduce bandwidth if you're sending files over a network. So we have got certain compression formats, out of which Gzip is the most popular one, used for compressing web pages, CSS and JavaScript files. We also have deflate, which is also like Gzip but not with much difference. Then you also got Brotli. So Brotli is the newer and more advanced compression algorithm developed by Google. It's widely used in modern browsers and can offer better compression ratios than Gzip. You can refer to all these compression formats as algorithms. We don't have to know about their internal working. We have got certain built-in methods that will help us in compression and decompression. So corresponding to Gzip, you have got Gzip and Gunzip, which compresses and decompresses the data respectively. You got zlib.deflate for compression and zlib.inflate for decompression. Then zlib.brotli compress, that uses the Brotli algorithm for compression, and zlib.brotli decompress, this uses the Brotli algorithm for decompression. So there are basically two ways that you can work with the Zlib module. First one is that you can work with strings. You can compress or decompress a string. On the other hand, you can also work with streams. You can compress or decompress files using streams. So first one, we are going to implement how to compress a string. Later on, we will decompress it as well. So I'm going to create one file. Let's say I'll just use one algorithm. The rest you can explore yourself. Gzip.js. So first of all, we are going to import. You have to import the Gzip, which is a named export from Zlib from the Zlib module. You need a data. You need a string that can be compressed. Let's say this is a Node.js class. So this is the string that I am specifying here. Now you want to compress it. You need to use Gzip. Data. The first parameter is the data. Basically, it has two parameters. First one is the data. Second one is a callback function. Now inside this callback function, you further have two parameters. First one is the error. Second one is the buffer. Now you need to handle this error. If there's an error, then return console.log the error. Otherwise, you can console.log. Simply you need buffer.toString. You need to convert it into the string format. Let's now run this node gzip. So what you see, what your function is doing, the function compresses your string using the gzip algorithm, which creates a binary buffer. So as you can see, the binary data isn't easily printable or viewable in the terminal. So for this, we are going to use an encoding base64. Now once again, you can check the result. So this is what you see. You need to use base64. This converts the binary gzip result to a base64 string. So the output that you are seeing now is exactly that. That is the base64 encoded version of the compressed binary. So the way I have specified this program is actually using the ES6 format of importing the modules. But most of the time when you look at the websites or certain sources, you will see that they will be using the common JS way of importing the module. So which actually looks like this. That is, you need to create a variable that is, let's say const zlib equals to require zlib. So I'll just comment out this one. So always remember, whenever you're using the common JS way of importing the modules, you must attach zlib because you're creating a variable here, zlib.gzip. Now if you check the result, this is also going to give you the same result, but right now it did not work. If you remember, we had changed something inside the package.json. We had written here type as module. So if you just remove this line and then you run this code, obviously that's going to work. So this was just a way to let you know that most of the websites are showing you these kinds of examples, but there's no need to worry. It's better if you use the ES6 way of importing the modules. Now let's decompress the string. So for decompression, first of all, your string must be compressed. So we have already compressed it. All you have to do now is utilize your gunzip. We will use gunzip. Now inside this, you have to put the compressed data, that is the buffer. This accepts a callback having first parameter as error, second parameter as the compressed buffer. Now you can console.log buffer.toString, and we have to use the encoding as UTF-8. That's an arrow function. So we can check the results for this. So what will happen, first of all, it's going to compress your data. It will print the compressed data, will take your compressed data, the compressed buffer as the input, and then will decompress it using gunzip. Let's check. You need to write node gzip. So first of all, it is compressing and then it is decompressing. So you have got the same result. All right, so till here, I hope it's clear. Now let's level up. Now in the second example, we will compress a real file using streams. This is useful when working with large files. Let's create a file. I'll create it with the name, let's say compress zlib.js. So first of all, let me just use the common JS module, common JS way of importing the modules. Later on, I'll just show it to you how you can use the ES6 way. So first of all, we will have to import the fs module, require fs, then you have to require or import the zlib, right? You have to create a readable stream here using, let's say I'll create a variable const read stream equals to fs dot create read stream. So this is going to take a file as input, for example input.txt. So I need to check if we have input.txt. Okay, I think, yeah, so we are already having it, input.txt. Now further we have to create a writable stream const write stream equals to fs dot create write stream. So for compression, because it will be using the Zlib module, we will be basically using the Gzip function here, Gzip algorithm. So what we want from the create read stream, it's going to read this input.txt and will create a compressed file. So we need to use, let's say input.txt, the extension will be gz. Right, now where's the algorithm? For that you will have to once again create a separate variable const gzip equals to zlib dot create gzip. Then you need to mention read stream dot pipe gzip dot pipe again, it's gzip dot pipe, and the write stream. Before I explain the very last line, I suggest you to go through the last video in which I have explained about the pipe method. So in this, it is taking input, that is input.txt, which is the read stream, gets converted, or you can say gets compressed using gzip, and then the result is written to the write stream, which is input.txt.gz. Can we now expect an output, or you can say a compressed file? So let's see, node compress zlib. So we need to check it here since we haven't printed any kind of response here, right? So you can see that a compressed file has been created. I hope the things are very clear now. As I also explained, I will be telling you how to import these modules using the ES6 way. So first of all, you need to comment out these, and you have to import the named exports. So whenever we use curly braces, always remember these are the named exports from that particular module. So first one is create read stream, create write stream from the fs module. Further, we also need to import a named export from zlib, that is create gzip from the zlib module. Import, right, and you need to delete zlib dot fs dot. Check the result again. You're going to get exactly the same result. So why it's not working? Because you need to come to package.json and type should be module. Now when you check the result, it would work. Pretty interesting, right? Now imagine you have been given a compressed file and you are required to decompress it. I leave that up to you. Also, please do explore the other two algorithms, that is deflate and broadly. And that's all for this video.